Okay, hi class. Today we're going to be covering section 4.6, which covers logarithmic and exponential equations. This is quite a long section because there's a lot of different types of example problems that you need to see. So I'll be breaking the video up into quite a few different smaller pieces so as not to have it be too overwhelming. And this is going to be the lesson for Monday and Wednesday this week is only section 4.6. Okay, so let's first start with the note that in order to solve exponential equations, the following property from the fact that the logarithm function is one-to-one can be useful. If you have the log base a of m equals the log base a of n, so same base, then we can say that m equals n. This just follows because I can take a to the power of both sides and then cancel. Okay, so that's because the function has an inverse because it's one-to-one. So we use this extensively together with the rules of logarithms in 4.5 and other things that we've done earlier to solve these equations. So the first one is the log of x plus 1 minus the log of x equals 2. So if we want to use the property above, we need to basically take the two logs written on the left-hand side and combine them together into one log. Okay, so here we have the minus, and we know that we can take two logs of the same base into one log where subtraction becomes division. Okay, so once we have this, then we use the fact that the logarithm function is one-to-one to get rid of the logarithm, or in other words, to get the x out from inside the log by taking the exponential to both sides. Remember, ln is log base e. So by the inverse property, we have cancellation on the left. Excuse me. So on the left side, we have only x plus 1 over x. And on the right-hand side, we have e squared. Not 2, but e squared, because whatever I do on one side of the equation, I have to do on the other side of the equation. So now I have to solve for x. I prefer to simplify the fraction by writing it as x over x plus 1 over x equals e squared. X over x is 1. So I have 1 plus 1 over x equals e squared. Now at least I only have x in one place. I have to get x by itself, so I'm going to subtract 1 to both sides. When I do this, I will get 1 over x equals e squared minus 1. And finally, to solve for x, I will take the reciprocal of both sides. That is, I will take 1 and divide it by what's on both sides. So I will have x equals 1 over e squared minus 1. And that's all I have to do to solve the logarithm equation. Okay, let's try something similar on part B. Here we have two log base 6s, and these are combined with a plus. So by the properties of logarithms, I can bring them together into one log, base 6, and inside of the parentheses, the addition will become multiplication. Okay, once we've succeeded in getting one log, then we will apply its inverse function and take 6 to the power on both sides. That's because it's a log base 6, so the inverse function is 6 to the x. Okay, we are left on the left-hand side with x plus 4 times x plus 3, and on the right-hand side, 6 to the first power, 6. Okay, so I should probably multiply out the left, FOIL it out, so I'm going to have x squared plus 4x plus 3x plus 12 equals 6. And I want to put the 6 to the other side so that it's equal to 0, so that I could either use the quadratic formula or factoring method. So upon subtraction by 6, I obtain x squared plus 4x plus 3x, 7x, plus 12 minus 6, 6 equals 0. Now we have a quadratic equation, our favorite. So either try to factor it, in this case it works, or simply go directly to the quadratic formula. I choose to factor it as x plus 6 times x plus 1 equals 0. And using the zero product rule, I get x plus 6 equals 0, or x plus 1 equals 0, which means x equals 6 and x equals negative 6 and x equals negative 1 are my potential solutions. However, this is a log equation, so I need to be very careful in this case. Okay, I wasn't as careful in the other one, but probably I should have done that too. So we can go back and I can show you what I mean there. But this one, we really have to be careful because it makes a difference. Okay, so what am I talking about? We need to check and make sure that both of these solutions are really actual solutions. That is to say, if these answers are in the domain. So let's briefly review that the domain of log base 6 of x is only positive values of x. Now here we have the log base 6 of x plus 4 and x plus 3, so those are shifted over. So in this example, here I need x plus 4 to be positive, and here I need x plus 3 to be positive. So totally what that means is that the domain of our function on the left-hand side is going to require x to be greater than negative 4. Okay, and so we can only plug in values of x that are greater than negative 4. So we look and we see negative 1, it is greater than negative 4, so that's fine. But negative 6 is not greater than negative 4. It's not really an answer, so we have to cross it out. Okay, so the only actual answer is x equals negative 1. Another way that I can explain this is just try plugging in the answers and see if they're okay. So you can try to check x equals negative 6, and if you do, you would get the log base 6 of negative 2, and already right there, this is undefined, so you have to stop, okay? So I said on the first one we didn't check, but on the first one we got 1 over e squared minus 1 as our answer, which if you put it on your calculator is approximately 0.15, which can be plugged in for the log of x and the log of x plus 1. So this was a real answer, not a fake answer. But especially when solving log equations, because the log has a restricted domain, you must always check and make sure that your answers are in the domain of the function.